friends! Welcome to Coding Garden with CJ. Welcome to Code Katas number 21. And I must say, it has been way too long since the last time I streamed. I've talked about, I started a new job, I'm getting used to that, and I'll start streaming more eventually. It'll probably happen soon, but hello! Welcome everyone. Let's say hello to all the wonderful people that are here. Hello, Wally Oxen, welcome to the stream. Hello, Amy, welcome. Hello, El Barate. And hello, Carlos. And Mr. Marco D, welcome. And Jackson, welcome to the stream. And Mahadi, welcome to the stream. Kaizen, it's been too long, welcome. Wally's asking, was the intro video different or is my memory just that terrible? It's the same one, and honestly, it's been the same one for like 6 months now. I should definitely make a new one. All right, let's get into it. So, if you are new to the Code Kata streams, I have a GitHub repo. It's github.com/codinggarden/code-katas. And here you can see all of the past katas that I've solved. I have links to the ones that I plan to solve tonight. And there is an issue thread on here where you can suggest other code katas for me to solve. I think 2 of the ones from tonight are coming from suggestions. So I will be doing, which one is it? I think I chose matrix determinant. Yeah, and I think that's going to be a little bit tricky, but this one was suggested by Savik, who I think is gaming but not really, in the Discord and on YouTube. We'll see, but they suggested that one. I'll be doing that one. And then there was someone that suggested a 7Q called distributing candies fairly, but they kind of got lost in this thread, but that's going to be the first one that I do. But if you have a suggestion for a kata, you can throw a comment here, and I will try to do it in the next episode. Without further ado, let's get to it. The ones I picked are not super easy, so we're gonna I don't want to say struggle. We're gonna learn. We're gonna work our way through these problems. Hey, Really Cygnus, welcome to the stream, and hello, Pratam, welcome. Chance, hello. Kaizen is asking what's in the background image, but maybe it's changed already, so I have no idea. We can watch the video. Cool. Okay, so first up is a 7Q, and these are in order of increasing difficulty, so we're going to start fairly easy and get more difficult. So this one is called distributing candies fairly. The next one is a 6Q. It's called Vasya, who's a clerk. The next one is a 5Q. Did I finish my Sudoku? And the last one is a 4Q, which is finding the matrix determinant for an n-by-n matrix. Okay, let's get started with distributing candies fairly. And so what I like to do is create a file locally. Distributing candies. We'll bring the function in, and oh, weird. Oh, okay. Then we'll test this. Fun thing. I might actually reach 1,000. I don't know. This is my score, my points here on Code Wars. So you all might witness history tonight. So that'll be fun. Okay, and then I'll start up Quokka, which runs my code inside of the editor. What's the error I'm getting? Cannot read property sort of undefined. Oh, so by default, we'll just return an empty array. And we have our test running. Cool. So let's read through this problem. There are some candies that need to be distributed to some children as fairly as possible. The variance of result needs to be as small as possible, but I don't know how to distribute them, so I need your help. Your assignment is to write a function which, with the signature, distribute m and n. M represents how many candies there are. So this is how many candies you have to give out to the children, and n is how many children there are. So in most cases, you'll end up with an array that is length n that has a number of candies for each child in it. Okay, so the candy can't be divided into pieces, so there are no fractions. It has to be whole candies. And if the number of candies to distribute is like 0 or negative, then they get nothing. So in our test cases, if we need to distribute -5 candies, we just return an empty array. If the number of children is ever 0, we return an empty array. If the number of children is ever negative, we return an empty array. But if, for instance, this case, and I think we can see it in here. So we are given, this is interesting. So we're given 5 candies, and we have to distribute that amongst 10 children. So you return an array where the back of the array has 1 candy for each kid, and then all the people at the front of the array have nothing. But actually, that's exact opposite to how they're testing it. I think we'll go with what's in the sample test, but essentially you backload the back of the array and then stop filling it once you're out of candies. And so in the case of 10 candies and 10 children, you end up with an array where there's 1 candy for each child. Then it gets interesting. If you have 15 candies and 10 children, the children at the back of the array get 2 candies and everyone else gets 1, and this sums up to 15. So basically, you have to distribute it out to the number of kitties. Kaisen is saying m divided by n, done. Maybe? I would probably do it, right? I don't know. We'll figure it out. Let's handle our base case though. So like, all of these are filling right now. Well, they're technically passing, but we should really only return an empty array if m is negative. Let's write some pseudocode. So if m is negative, or if m is negative, if m is 0 or less, or n is 0 or less, return empty array. So that'll handle all the cases where either the number of candies to distribute is negative or 0, or the number of children is negative or 0. Cool. For the other cases, we're just going to have to iterate. So first, we need a place to store the candies for the children. So need an n-length array to store the candies. Okay. There are multiple ways to do this. So what Kaisen suggested, m divided by n, that could be, if you math.floor it, that could be the most number of candies you could distribute to each kid, and then you backfill it with that, and then maybe fill the rest with ones. I think in my first solution here, what I'm going to do is basically a full pass over the array. So we have an array that's the length of the children, and we have a number of candies. Then we'll iterate over the array and just start putting in candies one at a time. And then when we get to the end, if we still have candies left, we'll go back to the beginning and put 1 in. And by the end of it, we'll have distributed all the candies. So let's say iterate up to the length, iterate up to number of children, which is n. And actually, let's do this. So we need an n-length array to store the candies filled with zeros. So initially, it's just an array with a bunch of zeros in it. And now when we iterate, we will increment the current value at increment the current value at the current index by 1, decrement the number of candies left, and repeat. If number of candies is 0, break out. We're done. If we reach the end of the array, we need to do it again. Yeah. if we reach the end of the array and still have candies left, do it again. And then finally, we will return the array of candies, or array of distributed candies. Let's just say return array. Cool. Danielle says, incoming random comment, but I love the sound of your keyboard. Thank you very much. It is a mechanical keyboard. It's nothing special, but I do enjoy it. Wally Oxen is mentioning you don't need to return an empty array if m is 0 or less and n is more than 0. Let's double check that. So, oh, I see. Like in this case. So if m is less than, but n is positive, you actually just fill it with zeros. I see. So really the logic should be if n, number of kids, is positive, return an array. Otherwise, return an empty array. Cool. And hello, Oliver. Welcome to the stream. Okay. So yeah, let's update our pseudocode. So if n is 0 or less, return empty array. Yeah, otherwise we're going to fill it with zeros. Cool. Okay, let's write some code. So if n is less than or equal to 0, return empty array. Okay. Otherwise, we need an n-length array to store the candies. So let's say candies, I think we can do array.fill. So we need an array of length n that has zeros in it. Maybe I do array.from length n, and then fill that with zeros. And then otherwise we return candies. That does it, right? So in the case where we need to return a full array of zeros, that's working. I wonder if there's a better way to do this, though. If anyone thinks of a better way to create an empty array, well, an array of a given length filled with zeros, let me know. But for now, we have that. Cool. And hello, Vyas. I'm doing well. It's a good day. Having a good day. Okay, so we just did that. Now, iterate up to the number of children. So let's just do a for loop. Candies. So now we need to do all of this. Increment the current value at the current index by 1. So we'll say candies at I plus plus. Decrement the number of candies left. So we'll do m minus minus. If the number of candies is 0, break. So if m is equal to 0, break. Okay, so this should handle most cases. And really, I guess we should check before we do this iteration. If m is less than or equal to 0, then we just return the candies already. Okay. So in the case where there's -5 candies and 10 kids, everyone gets nothing. So that should be working right now. Cool. In the case of 5 candies and 10 kids, you should end up with an array with 1s in it. That's great. We're doing it. In the case of 10 candies and 10 kids, you just have an array with a bunch of 1s in it. We're also doing that. But now we need to handle this last case where we have, yeah, so we've reached the end of the array, but we still have candies left. Now we got to do it again. So let's do this. I want to put this in a function. Yeah. So let's put this in a function called like fill candies. And oops, I lost it. Whoa. Okay, so we have fill candies, which is going to be a function that does that. And we'll need to call fill candies. I guess we'll just say while m is greater than 0, we will fill the candies. Have I created an infinite loop? No, we've done it. Cool. So what's happening here? Basically, I took that for loop that I wrote, and I'm just calling it again and again until candies is down to 0, because inside of here, we're actually decrementing m. Cool. Yeah. There are some suggestions for how I can create an empty array of zeros. So let's like write out all the ways to do it. So I do like what Oliver suggested. This array.from accepts a callback, which is essentially like a map, and we can do that. And what this does is it calls this function for every element in the array, and the array is going to be length n and return 0. So then you end up with zeros in the array. So that's pretty cool. Kaizen is suggesting we could also do array, and I think this makes sense. So you say array of n, so I want an array of that length, and I want to fill it with zeros. Does this work? This also works. Cool. This is like the least amount of syntax, so that's cool. And hello, JT. Welcome to the stream. Okay, so this is working. Let's throw it into Code Wars to see if it works. But then let's try to write it some other ways. Maybe refactor it a bit. It works. Okay, so let's try to clean this up. I guess technically, like, this didn't have to be in a function. Like, I could just put this for loop directly inside of the while loop. Let's just see what that looks like. I think the thing is I could probably make this somewhat recursive, where it like keeps filling. Yeah, I don't know. We'll see. But technically, this still works. I guess there was a suggestion earlier from Kaizen where you take the number of candies, divide it by the number of children, and you have, I guess, the maximum that you can give out to each kid. So, like, if we took 15 and divided by that by 10, we get 1.5. So what we could do is perform this calculation, round up, we have to figure out when to stop this. So I was thinking round up, start filling it with 2s, but then, or in this case 2s, and then how would we know that we now need to start filling it with 1s? I don't know. That'd be tricky. Yeah. I don't know. Oh, I like it. So Oliver's saying im mod in tells you how many will get one extra. Okay, so let's write this from scratch. We have our base logic there, but then we'll say like max candies is im divided by n, the ceiling of that. Okay, and im mod in will tell you how many get that number of candies. So iterate up to im mod in fill with max candies, and then iterate from im mod in +1 to the end and fill with max candies -1. Should that work? Yeah, so Wally says, do the division, fill the array with math.floor of that, then loop the rest. Kaizen just says, yes. Will this do it? Let's try it. So let's say max candies is math.ceiling of m divided by n. So in various cases, those are our max candies. We want to iterate up to im mod in. So let's say for I equals 0, while I is less than im mod in. We'll say candies at that index equals the max candies. And then we now need to iterate from there to the end. Well, and I guess it doesn't have to be +1 because we're doing less than. Does it need to be less than or equal to? I don't know. And so I will start at im mod in while I is less than in, and we'll say the candies at that index will be max candies -1. Okay, does it work? We broke it for this case. And this does need to be less than or equal to n + 1. So this needs to be less than or equal to, and this needs to be +1. Wait, what? I'm doing everything wrong. Wally is saying their way only had one for loop. Anaboth is saying every kid receives im divided by n candies and then iterate im mod in and give one more candy. That makes so much more sense. I like that. So we'll say min candies, and that's going to be a math.floor of m divided by n. Okay, so everyone gets that many. And then im mod n of them get one more candy. So here's what we can do. Just have a straight up for, you know what? Let's use for each. So let's say like candies.for each. That's going to give us, oh, no. We could do a map here. So we're going to map the candies. So we're given the current value, which I don't think we need. We're given the index. And here's the scenario. If I is less than im mod in, give them min candies +1. So return, okay, so if I is less than m mod n, then we're going to return min candies plus 1. Else return min candies. Does it work? It works. That's great. So what's happening here is if the indice, basically we're filling it with the people that get 1 extra candy, and then after that everyone just gets the regular candy. Cool. Thank you, Anaboth, for that. That was a good suggestion. And then we could probably one-line it, because why not? So we'll do that. I think this technically works. Let's say, okay, can we one line this whole thing? So if n is less than or equal to 0, else if m is less than or equal to 0, then we want that. Else we want this. And really, this is where I could do I know. But now, instead of doing map, we can actually just do this right here. Ta-da! Okay, so if n is less than or equal to 0, return an empty array. Else, if m is less than or equal to 0, return an array filled with zeros. Else, return an array of that given length, and then we have the math for each value in the array. Wow! Well, he's saying, but is that line more than 100 characters? Probably. Could probably make it less. That is 143 characters, but it has spaces and long variable names. Okay, let's see if it works. Nice. All right, we're going to do the attempt. Sweet, I got 2 points. Final. Cool. And plus plus array at I mod n. What? Okay, create an array filled with zeros. Now go from 0 up to the number of candies. I see. And then the array at the given index, so they're looping around. So I mod n is looping around. So this essentially was our very first solution. It's just written in a different way. Like they're looping up to the number of candies rather than just looping over the array. But ultimately, they fill it, and then they fill it again and fill it again until the whole thing has been filled. Cool. Wally's saying Airbnb linting doesn't like that solution. I know, like Airbnb does not like nested ternaries. I know that for sure. I've been using Airbnb at work. Okay, so fill it with zeros, create an array of length m mod n, and fill it with the maximum number. Oh, okay, yeah, so this is an interesting solution. So you create one array that's the maximum number and one array that's the minimum number, and then you just put them together into one array. Cool. All right, that was a fun one. Let's keep moving. Next one is Vasya, who is a clerk. So let's pull it down locally. Okay, so let's read the problem description. The new Avengers movie has just been released, and there are a lot of people at the cinema box office standing in a huge line. Each of them has a single $100, $50, or $25 bill. In US dollars, there is no $25 bill, but I'm sure in other places there are. But essentially, you have those three bill denominations, and a ticket to a movie costs $25. Your task is, given the people in line and in order, can you sell each of them a ticket and have enough change to give for each person in line? So, and so these tests are testing that one. Let's also test this one. And this should be no. So you return yes if you can sell a ticket to every person and give them enough change, otherwise no. So in the case of this line, so the first person pays $25, great, no change. Next person pays $25, great, no change. The next person pays $50, but you have two $25 bills in your cash register, so you can give them $25 change. Cool. Kaizen is saying, are those real ticket prices in the US? No, but it's close. Like, you'll probably end up paying, like, I guess it depends on the movie, but, like, maybe $15 or so for a movie. I don't think this is US dollars. And it also depends on the type of movie theater that you go to, because there's, like, IMAX and 3D, and they upcharge for all that stuff. But yeah, and Wally's saying that's just for the ticket. The popcorn is, like, $20. I don't know, a Coke is like $10. Okay, so how will we do this? I'm thinking we need some sort of like cash register. So basically a place to keep track of what bills we have, right? And then we will iterate over the line. For each person in the line, we need to check and see if the cash register has enough change to give them. If so, put money in register. So we'll need to put the money in the register, give change, so that's taken out of the register, and then repeat. And then if there's not enough, if not, we will return no. And if we made it out of that loop, we will return yes, because we made it to the end of the loop. Cool. Yeah, Marco is saying reduce incoming. Maybe. I'm going to solve it like with a for loop first, but then we can probably coerce it into a reduce or something like that. Because basically you're reducing an array to a single value, yes or no. So yeah. Okay, so we need a cash register, which is a place to keep track of the bills we have. I want to say something like this. We'll say like $25 bills, we have none. $50 bills, we have none, and $100 bills, we have none. So we start off with a totally empty cash register. And then we iterate over the line. So let's do a for loop over the people in a line. And let's say this is the payment is the given person in line. So we need to do these things. So check if the cash register has enough change. So how do we do that? I guess if they're paying with, I guess let's do the simplest case. If they pay with a $25 bill, great. We'll put it in the register and keep going because we don't have to give them change, right? Yeah. Yeah, and people in the chat are mentioning people would use credit cards, not cash. I don't know. Okay. Check if the cash register has enough change. So, basically, well, really, we also want to check what are they paying with. Because I kind of want to say, like, if payment is equal to 25, continue on. So if the payment is equal to 25, then we just put it in the register, right? So we'll say register at payment plus plus. And we don't have to give any change. Yeah. I guess let's write this just very verbosely, and then we'll try to pare it down. So else, if payment is equal to 50, and the register has a $25 bill in it, is greater than 0, then we'll say register at 50, well, which is their payment, plus plus, and register at 25, because that's the change we're giving them, minus minus. And then else, if payment is equal to 100. Now, I realize this is a lot of code, but if we get it all out, we can start to refactor it and make it simpler. So I think we're just going to have a final else return no. And then here we'll return yes. Okay, so now, tricky case for 100. So if the payment is 100, we need to check for $75 in change, right? Yeah, and Vyas and Wally and a few other people are mentioning, what if the first person in line gives more than $25? Then it'll immediately fail. So, like, if I is 0 and the payment is 50, but there's nothing in the register for 25, it's immediately going to return no. So we have that covered. Yeah. Rostel is mentioning needs 25 and 50. And Vyas is saying, what if the first person in the live gives more than 25? Yes, I think we've covered that, I think. And actually, let's start up Quokka. Because technically, we haven't handled 100 yet, but this first one works, which is great. And if we tested it with like a 50, it should just immediately respond with no, and it does. Cool. But now we need to handle 100. So if the payment is 100, and okay, so if we have if the register at 25 is greater than 2, meaning let's do this logic inside of here. So basically we need to check if there is enough money to give them 25 and change. So if register at 25 is greater than 2, meaning it's at least 3, then we can take their payment. So we can say register at their payment, which is 100, gets incremented, and then register at 25 gets decremented by 3 because we have to give $75 and change. Now, if we don't have at least 3 there, but we have 2 and 1. Wait, if we have 1 and a 50, we can give change, right? Because that's 75. So if register at 25 is greater than 0, so we need 125 and 150. 50 is greater than 0, then we're going to give them back 150 and 125. Cool. And I want to increment their payment after all these things. And I like this is ugly. There's a lot of logic here, but it breaks. So, oh, really? We need to return no right here. It's a little clunky, but yeah. So somebody steps in line with a 50. There's no money in the register. No. This case, 25 even. This person gets back 25 and change, and then this person gets back 25 and change. So that's yes. This is a no because the first person pays with 25, no change. You try to pay with 100, don't have enough change, so it's a no. And yeah, so pay with 25, 25. So we have enough change for this, we have enough change for this, but we don't have enough change for that. Okay. But now let's clean this thing up. So this is my first go at a solution. It's ugly. There's a lot of code here, but we can definitely refactor this. And whoa. Okay, there's some chat. I gotta catch up. Okay. While he's saying all these sad people going to the movies alone. I mean, maybe they're just paying for themselves. I don't know. While he's saying, should you bias giving back a 50 and a 25 over giving back 3 25s? I think so. Because wait, am I not doing that? Right, so like in this case, I'm giving back more change. So should I check this one first and then do the next one? Yeah, I think that makes sense. Because that way, you're giving out less bills in your cash register. So if they pay with 100, we try to give them back a 25 and a 50. But if we can't, we try to give them back 3 25s. I like that. Let me actually fix that up here too. Cool. Yeah, so multiple people were saying I should give back 50s first. Which is what I'm doing there. Cool. Okay, but how can we clean this up? So we did talk about earlier, we potentially could do a reduce. I feel like, what do I feel like? We could break these if-else's into like an object of options that like given, or like a switch statement. So given a specific payment, we try to give them that amount of change. Hello, Alka. Welcome to the stream. Coding challenges are okay. I feel like my code on all of them has been like kind of ugly. It's getting better though. I don't know. I think it's been 2 weeks since I last did a Kata stream. Yeah, I don't know. Does anyone have any suggestions for how I can clean this up? I think let's try to turn this into a reduce. It may not look pretty. I mean, it's going to look very similar, but yeah, let's just do a reduce. Oh, really? Actually, I don't know if I like a reduce. I think I like an every, because you want to make sure that everything in the array returns true. Yeah. So test whether all elements in the array pass the test implemented by the provided function. Because if any one of them returns a false, then it's going to return a no. Let's do this. So all of this wonky code is going to go inside of the every. And then we can say if everyone returned true, then we say yes. Otherwise, we say no. And that works. Cool. Yeah, we could do a switch statement. I feel like there's better ways of like calculating change. It could be instead of, because we have this object, but maybe I want a way to like dynamically iterate over it and see if we can give change with that. I think that's definitely where I want to go with this solution eventually. Hello, Tiger. Welcome to the stream. But yeah, let's do this with a reduce. It is possible. I think it is possible with reduce. So we'll say valid is the thing we're reducing to. And I guess we'll default to the empty string. So what are we reducing though? I feel like this isn't right, but what should happen is, so if valid does not equal no, then we return yes. Otherwise, we return no. Because ultimately, I don't know, this is weird. I'm doing this weird. Because if any one of these return no, then the next time around, if valid is already no, we just need to return no. Yes, and it is actually 9:15 p.m. here in Denver. Yeah, it's 9:15. No, I have 2 more katas to do after this, so I will be streaming for a while. Yeah. Okay, so that works. I honestly don't like this one either. I kind of want to do this from scratch and just like make change. Let's make change. So, well, we have all of this logic, but this. Okay, so guess what I'm thinking is potentially the register has nothing in it, and then we like keep it sorted. So like, okay. Check if the register has enough change. So we'd want to like iterate over the register and say like, no, I don't think I want that. Basically I want to do this dynamically though, instead of having all these if-else statements, because because, I don't know what, I just said because for no reason. I'm having a hard time thinking through this one. So if the payment is 25, great, we're done. I like this. Now this. So Kaizen is suggesting, and I like this. I don't know if it's going to work, but I like where he's going with this. Can you make it so that each slot in the register is an array, and you just pop in push based on availability? I like it. Yeah. Okay. And hello, Himanshu. Welcome to the stream. So if the payment is 50 and register at 25 dot length is greater than 0, I mean, technically it's kind of doing the same thing. But now we'll just say register at 25 dot pop, because you got to give them change. And then register at payment. What are we pushing in, though? It could be anything. I guess we just push a 0. If the payment is 100, I mean, technically, we're just kind of doing this, right? So instead of modifying numbers, pop, pop. Well, here we got to pop 3 times. Pop. Does pop take a number? No, it doesn't. 1, 2, 3. It's more code. It is an interesting way to look at it, though. I think one thing we can maybe refactor is this. The pushing of... Oh, and this will have to change. And this still works. I guess technically I don't have to push anything in. I think if you just say push, it'll push in undefined, but really we just need the length of the array. That didn't work. Okay. Pop, pop, pop. But I guess what I'm thinking is... can make change. False. Well, we'll say true. Where are we at here? And then here we'll say can make change equals false. Can make change equals false. And then at the end, we'll say if can make change, then we will do the pushing of the payment. And then we don't have to do it in all those places. And we can get rid of that, I think. Oh. I think we still need to do that. Then we can say if can make change, then we'll push in. And we actually can get rid of this check. Leave. No, I broke it. This one broke. That was it. Cool. Marco is saying, perhaps test if register at 25 is greater than 0 first. Yeah, and I guess I'm doing that here. Has anybody posted anything in the Discord? No. I'm really coming up short on this one. Like, I imagined like a very elegant solution. Just for fun, let's do what I was initially talking about, where like instead of like a switch statement, we make this into like an object. Okay. Here we go. So, payment options. This is going to be an object. So, there's going to be some function at 25, some function at 50, and some function at 100. Watch. This could be interesting. Here we go. Here we go. Okay, so we've got these options. For 25, we just add it to the register. For 50, we have to do our check. And if it doesn't work, then we return no. And then for 100, we have to do all of this. Okay. And so what we'll do is we'll say this object at payment invoked. And we'll say this is like the result. And if result is equal to no, return no. Does that work? It does. I think we can make it even easier, though. We can kind of do what we did before, so get rid of all of these increments. And we'll throw this here. So this is just going to return undefined, and so it'll increment that payment. This will return undefined. Yeah, that works. Is it cleaner? I don't know. I really don't know. Oliver is saying, you should see my elegant solution. 236 characters of pure one-line unreadable joy. Is it in Discord? Post it in the Discord so I can take a look. Chance is suggesting maybe create a give change function and return yes or no based on the value returned from that. Yeah, I think that's kind of what we're doing here. What if I can clean it up by not returning no here? Okay, this is Oliver's solution. Let's check it out. Here we go. Doing a reduce, we have our accumulator, each item, and the index. So we've got an object. Yes, it's an object. And I don't even want to try. So if, I guess you're doing something similar. So if, are we indexing into... What do the V, S, and M mean? Yeah, I could bust... I'm not even going to try it. So that was fun. I think I could turn this into a one-line solution. Let's just do that. That's the last thing I'll do here. So what I'll do is we'll do this, but with the every solution. So we'll do this, and then all of our codes go here. Really what we want to do is something like this. So that returns true. This returns false. So, why is this complaining? So if it returns true, then, well, really we want to return this. But I'm still missing where we add it to the register, because we want to do, if this whole thing returns true, then add it to the register and return true. Otherwise, return false. Does that do it? But then we need to say here, if everyone is true, then we say yes. Otherwise, we say no. Comment this one out. That works. Wow, that works. Okay. So to make this a one-liner, we're going to grab the register. We're going to have to reuse it. Oh, no, 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 no. We still need a register. We'll put it as a default parameter, like that. Cool. Does that still work? Yes, it does. Now, this whole thing can be a one-liner, like that. I guess technically you don't even need the, I guess you do need the curly brace, the parentheses, because it might confuse the curly brace there. Does that work? That works. Do I want to go any further than that? I think actually I kind of like this solution. Like it's not as verbose. It takes a little bit more to understand, but I like it. Oliver's mentioning about their solution. It's a destructured accumulator with 3 keys. Ah, I see. So, because there's 2 parameters. So this isn't accumulator value index. This is the accumulator that you're pulling off the keys from, and that's the value. I see. Because the accumulator starts off with V, S, and M. Oliver approves of the comma separator. So that's this right here. So basically, what I wanted to happen was if this thing returned true, I wanted to add it to the register. And then also return true in the every statement. Otherwise, just return false. Okay, let's just submit this one, see what happens. Works for the sample tests. Does it work for the full test? Ah, it works. Cool, I got 8 points. We're only 2 away from 1,000. We're gonna reach 1,000 this stream. That's great. Go. Heather's asking what makes this slash solution better than the first one with the for loop. Nothing, absolutely nothing at all. And honestly, if we're going by like just code readability, this one is probably their most verbose and like easiest to understand, right? Like, yeah, so there's absolutely nothing wrong with this solution. It's great. I do like the use of every, so I would probably prefer this one over this one. But in terms of like performance and iterations, they're both doing exactly the same thing. If you did want to get picky about it, this probably takes more computation because we have to actually store and invoke these functions. And these functions are getting created on every iteration of every, so this probably uses more memory in general. I just like the way it was structured and the way it looked. This very verbose one is probably the most performant, uses the least amount of memory. Yeah. Okay, so Oliver's mentioning, I thought of doing this, I just didn't know if it would work right. So switch out the ternary here with ampersand, ampersand. Does that work? Nice. So if this returns true, then add it and return true. Otherwise, it's going to return false. And move the dictionary of instructions into a higher scope. Yeah, I guess technically this, because that way it wouldn't get recreated every time. We could store this here, and then we can just reuse it right here. Because that way you're not, because inside of this every, it was literally, it had to recreate this object every time. So in this case, it creates it once and then reuses it. Yeah. Good call. Weird. Okay, let's keep moving. That was an interesting one. I really thought it was going to be easier than that, like less verbose than that. Ooh, the next one is, did I finish my Sudoku? This one's going to be interesting. So basically, you're given a Sudoku board, and you have to return finished if it's a valid solution, or try again if it's not a valid solution. So valid solutions are every row only contains the numbers 1 through 9 once, every column only contains the numbers 1 through 9 once, and every region, which is a 3x3 matrix. There's 3 across and 3 down. Well, 3, 3, 3, 3, 3, 3, 3, 3, 3, and each region only contains that number one time. So you have rows, columns, and then regions, and each row, each column, and each region can only have the number occurring once, cannot be repeated. So we're given a board, and we have to just verify that it is a valid solution. So let's get to it. New one. Did I finish my Sudoku? Sudoku. Have some examples. Cool. I think I will do this. Start up Baka. And right now our function returns undefined. See ya, Kaisen. Have a good day at work. Kaisen says his brain's all warmed up. That's good. Okay, so for this one, I think we basically have probably 3 functions to write, like check a row, check a column, check a region, and we have to do it for the entire board, and if they're all valid, then the whole thing is valid. Yeah, so let's do that. Pseudocode. Check each row. Check each row is valid. Check each column is valid. Check each region is valid. If all valid, return finished. Else, return try again. Okay, this is very high-level pseudocode. Let's talk about how we're gonna do it. And actually, we can write. Let's write functions to do this. So basically, for any one of these that we're going to do, we're going to have to keep track of all the numbers that we've seen, and we need to make sure that we've only seen each number once, and we have seen every number once. Cool. Hello, Daniel. Welcome to the stream. I'm doing okay. Had a good day. Okay. Yeah, so how do we check if a row is valid? The board is how long is it? Well, it should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9. It's a 9 by 9 array. So yeah, iterate over the rows. Each row. Keep track of numbers we've seen. And by that case, keep track of numbers that we've seen. Increment count of number by 1. If count ever goes above 1, it's invalid. If we see a number more than once, it's invalid. After iterating over the row, check to make sure all 9 numbers are accounted for. Like, it could be that maybe they had numbers 10 through 12 or something, and nothing was repeated, but it wasn't the numbers 1 through 9. So I guess we could technically check to make sure that each individual number is between 1 and 9, and then also check that after we're keeping track of it and incrementing it, we haven't seen it twice. Okay. Andrew Lane retracted their message, but they did ask, would a class be helpful? Possibly. Like, we could potentially create a class called row and then pass each row in the board in, like, create an instance of that class, and then maybe that class has functions like is valid. That could do it. Yeah. Oh, good call. Yeah, so Wally is saying, noticed in the second test, there are zeros, so you'll definitely need that valid number check. And really, that would help us out. So keep track of the numbers we've seen. Make sure current number is between 1 and 9, inclusive, and then increment the count. If the count ever goes above 1, it's invalid. I think that's good. And technically, like, this is our algorithm for like, no matter what, no matter if it's a row, a column, or a region. We may have to shift the data around to get this algorithm to work, but I think what I want to do is let's write this algorithm for an array. Let's just assume that it's an array that we can iterate over and make sure that the numbers 1 through 9 only occur once in it. If we get that working, then we can just call that function on rows. We can create arrays out of each of the columns. We can create arrays out of the regions and call that function again. So we can reuse our logic. I think that's the way to go. Yeah, so Rostal is mentioning the same, like, basically we want to reuse this function. So let's just take this logic and say is valid. And it just takes an array of numbers. We're going to do this pseudocode here. So we need to keep track of the numbers that we've seen. Say that's an object. And then we'll need to iterate over numbers. So let's just do a for loop. And we'll grab the value there. So let's make sure the current value is between 1 and 9. So if value is less than or equal to 0, or value is greater than 9, immediately return false. We found an invalid number. Done. Increment count of number by 1. If count ever goes above 1, invalid. So here, really, we can say, if we have seen this value, return false. Otherwise, seen at that, well, I guess we don't even need a count. We'll just say seen at value equals true. Yeah, and we're not incrementing it. We're just storing it as a Boolean. And if we get through all of that, then we should return true. So this, I'll say this real quick. This assumes numbers is an array of length 9, right? Because if we reach the end of this loop and we've looked at every number in the array and we haven't returned false yet, that means that we've only seen each number once. Because if we ever seen a number twice, it immediately returns false. Or if any of the numbers are not between 0 and 9, it immediately returns false. So this should do it. Yeah. So let's catch up on the chat. Ooh, there's quite a bit. Yeah. Sean says, "Hi CJ in chat. Hope the new job is going good." It is. I'm enjoying my job. I'm actually writing React on a day-to-day basis, but I'm enjoying it. It's pretty fun. I'm working with really cool people, and it's a cool project. Heather is saying, "Can you make an array 1 through 9, then store each data in another array, sort, then check if equal to the first array?" Maybe elementary. Yeah. I mean, the only reason I don't initially like that is because it requires a lot of computation, because you have to sort it and then but yeah, technically that's a really easy way to check, right? So, whoa, sorry, things are getting weird. But yeah, that's actually a really easy way to check. You say, like, let's say you have a predefined array like this, and you can't do this kind of equality in JavaScript, but you'd have to check each value and make sure that numbers.sort is equal. That's a really easy way to check that it has all of the numbers, yes. But what requires more work is, first you have to sort the numbers array, so that requires work. Then, in order to compare these two arrays, you have to iterate over both of them. JavaScript doesn't have a built-in way to just compare two arrays. You have to actually iterate. So it would require a bit more iteration. Cool. Andrew Lane is saying, does every give the index? And then if yes, numbers that I sort. Yeah, I think eventually I am going to use every, because basically I want every row, every column, and every region to be valid. Yeah. Cool. Yeah, everybody wants me to use sort. I'm not going to use sort. Maybe I'll use sort afterwards, but I don't know. I think this is one of those problems where I'm not going to do it twice. I'm just going to solve it. Leave that comment. But technically, this is valid function should do the thing. So if we log is valid with, like, let's only try it with the first one. So we'll say board at 0. We'll say is valid. True. Or board at, so and this checks each individual row. Board at 1 is valid, board at 2, board at 3. But if we were to change this to be like a 3 because it occurs twice, then it's not valid. So my valid function works, and it's actually really performant because it does like short circuiting. So the moment it finds that this thing has gone wrong, it immediately returns false. Cool. So we have our is valid function. So now we need to check if each row is valid. And this is definitely where we can use every. So we'll say rows valid will be board dot every row. And actually, I think I can just do is valid like that. What? So because every is a function. Well, no, sorry. Every is a higher order function that accepts a function which will get called on everything in that given an array. And because every value in the board array is an array, it's like passing each array into the isValid function. Cool. So that works. And if we try it, well, if we throw like a 3 in there, then this returns false because the first row was not valid. Okay. We're getting somewhere. Okay, so now how do we check if each column is valid? Basically, we need to extract out columns from the board. How can we do that? Let's catch up on the chat. Ollie's saying, just sort the array, and if the number after the current number is the same, then fail. Wait, what? Everyone wants to sort. I don't want to sort. Like, sorting's not always bad, but, like, it does take a bit of computation to sort. Okay, so in order to check the columns, we want to check, I guess, like, all 9 columns, right? So if I create a for loop that goes from 0 through up to 9, right? And create another for loop that goes for the rows up to 9. So there should be 9 rows and 9 columns. I essentially want to grab 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, right? So I guess we'll just call it numbers. And it's an array, and we want to say numbers dot push the board at the given column at the given row. So when column is 0, it's going to say row 0, row 1, row 2, row 3, row 4, row 5, 6, 7, etc. So this is going to create an array of the first column, right? And so we have numbers here. And then we'll say column valid is going to be is valid with numbers there. So that's going to check each one. So really, we could short circuit it. So we're going to check every row. So we'll say if every row is valid, then we're going to attempt to check every column. And if any column is not valid, then we immediately just I guess not return false, but we need to, well, I guess we could break out of here. Yeah. If the numbers in that column is not valid, we just break out. I think no. We're just going to return try again. Same thing here. Okay, so this checks the rows. This checks each column. And the cool thing about this is it immediately exits the moment it finds a column that is not right. Now we have to check the regions. How do we check the regions? Ooh, I like that. So Andrew is mentioning how we can do this with array.map. So could we do board.map? It's going to map over all of the rows. Yeah, that should do it. Like that. Nice. Okay. Because this is grabbing each row and then returning the value in the column from that given row. So this is 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 2, 2, 2, 2. Cool. And then we can immediately exit there. Now we need to check each region is valid. Cool. Oliver's mentioning sometimes the arrays have zeros. We handled that here. So in our isValid function, if it's not between 1 and 9, it immediately is not valid. It's not a valid row. Okay, so we're checking rows, we're checking columns. Now we need to check each region. How do we grab the regions? So we probably could do a map. Maybe not a map. How many regions are there? So there's 3 by 3 here. There's 1, 2, 3. 1, 2, 3. There are 9 regions. So 3 by 3, 3 by 3, 3 by 3, 3 by 3, 3 by 3. Cool. See you, Danielle. Thanks for tuning in. But really, yeah, so if right now our function is technically working for this invalid solution here, it immediately returns try again because there are invalid numbers in there. Cool. Maybe we create a function that extracts a region. So a region is going to be 0, 1, 2, 0, 1, 2. Then it's going to be 3, 4, 5, 0, 1, 2. Yeah, so we could create a function for grabbing a 3 by 3 region. Rostel is saying just like column, but grab 3 numbers. So yeah, so we don't want to iterate 1 at a time. We want to go 3 at a time. Okay, I like that. So we go from 0 to 3. Okay, so yeah, because this is going to give us 0, 1, 2. And then on the next iteration, we'll do 3, 4, 5. And on the next iteration, we'll do 6, 7, 8. So this has us covered for going across. Now we also need to go down. And our numbers are going to be an array that contains the first 3 numbers of the first row. So we'll do board at 0, well, not at 0, at column, because that's going to give us this. And we want to slice it to grab, start here and grab 3 of them. And that's the index that's not included, I think. So this is going to grab these 3. Then we need actually, it's going to be like this. I got it. And it's actually going to be board at row, column, and 3. That's what it is. Wait. No? Oh, it needs to be column plus 3. And no, this is not right, is it? I gotta step back. Wally sees what I'm doing, but I can't exactly figure it out. Let me double check slice. Array.slice returns a shallow copy. So you have begin and then end. Slice extracts up to but not including the end. So if we say board at 0, oh no, this just needs to needs to go up to 3, right? Let's think through this. Okay, so board at 0 is the row. We're going to slice it from column to there. Great, we have that one. Now we need to increment by 1 to go to row 1. We grab this one, and we increment it again, and we go there. So this, I have to work through this, but really that goes there. Why is this always logging an empty? Oh, we have to reassign it. That's why. So 534672198. Great. We have that first region. Then we have 912348 It's doing it, but we're only doing it for the first 3 rows. Yeah. I think we're there. So it is working, but it's only grabbing the first 3 regions. We need to move it down 1. Yeah, so this gives us 0 through 3. I mean, I don't know if I want to hard code this, but technically we would just do this again for rows 3 through 6, and then rows 6 through 9. Probably put this in a function, right? If I iterate up by, so yeah, I think this is one thing though. So like if this does go up to 9, am I grabbing the right regions? I don't know. No, that's way too many numbers. Right, because I need to do 3 at a time. Okay, I've got it. Okay. We're going to increment by 3 each time. But we need to do this like this. Watch me. Oh no, what did I lose? Technically want this. This is what I need. Huh? Huh? I think that does it. Okay. So yeah, 534-672-198, 678-195-342, 7. Wait. Oh, it's technically going down. So it's doing this region, this region, this region, then this region, this region. Okay, but this works. This works. Because each region is contained of 3 different rows. I think even this I could put into a function, but check this out. So now we can say if is valid is not, so if is not valid, that given region, return, try again. Done. And I think even this we could extract to a function. Wait. And then ultimately, if we make it past this if statement, we just return finished. Yeah. And this one should say try again. Cool. I could extract this into a function. I think VS Code has, okay, refactor. Extract to function in global scope. What should we call it? Get section. Did it do it? Yeah. This will be row +1, and this will be row +2. Cool. And then we could even extract this into a function that's like get region. Refactor. Extract to function in global scope. Look at that. That's nice. I like that a lot. Okay. Can we turn this into like an every or something like that? Let's see. I think we can, let's like reuse our functions, but let's try to rewrite this. So if board.every, if every row is valid, and if every column is valid, so we'll do We needed an array of length 9. Like so. Yeah. So create an array of length 9, so it's just an empty array, but then for every item, the index is going to be the column, so 0 through 9, and then for each one of those, we want to call is valid on that given column, and we want to make sure that every row is valid. So oh, sorry, these are columns valid. So that still works. That's good. And Wally's saying, single line solution, go. I don't know if I can get this one down to a single line. And we'll see you later, Heather. Thanks for tuning in. And Wally earlier said, very nice solution. Appreciate that. Cool. Oh, hey, Meyer. Meyer says, sup, CJ, long time no see. How's the new job going? It's going well. I'm enjoying it, writing cool codes and working with cool people. Cool. So yes, this checks if the columns are valid. I mean, really, we could say if every row is valid and every column is valid, yeah, and then how can we how can we turn this into a one-liner? I'm thinking like we technically need 0, 3, and 6, right? 0, 3, and 6. And we want to call every on that with, and this is going to give us the column. Whoop, 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 whoop. And then again, we're going to do 0, 3, and 6. And we want to call every on that. And that's going to give us the row. And we want to do this. This is some voodoo magic. So if every column and every row is, well, if every region is valid, basically, but where each region is consisting of a given column and row. So ultimately we can do and that stuff. And then that works. I realize I'm getting very silent while I refactor this, but this works. That's crazy. So what is this complaining about? Oh, no, it doesn't. I have a syntax error. There you go. But it still works. Okay. Yeah, but we can turn this technically into even more of a one-liner. Oh. Because this could technically just be this, and this could technically just be this. Yeah. We do have quite a few helper functions. So like, if we don't look at that, but we have these other helper functions, then that is pretty crazy. Wow. Okay, let's submit this on Code Wars. I think we need all of this except for the more verbose solution. So like, this can go away. Sample tests. It works. Should we attempt it? And is it going to put me past 990? Let's see. Go! Final solution. A 1,000! We made it to 1,000. That's awesome. 1,000 points. Woo! But yeah, someone mentioned I can turn it into a ternary. So let's do this. That's ridiculous. Well, I think I still have to wrap all of this in parentheses. So if all of that is true, then we return finished, else we return try again. Nice. Thanks everyone. Everyone's saying congrats. Appreciate the support. Cool. Yeah, that was fun. Let's see how other people did it. Is valid row. Yeah, so they kind of did the same. So they split it up into columns. They split it up into blocks or regions. Cool. Whoa, and then some interesting math here to figure out the regions, but that I'm assuming that this is grabbing a specific value from a specific region. Oh, I guess that's true. Wally's saying I had 998, and then it went down to 990. Yeah, I don't know why that happened. Weird. Yeah, because it was really close to 1,000, wasn't it? Maybe it goes based on time. Like if I had a specific kata open for a while, the points go down. I hope that doesn't happen. I don't know. Cool. I'm very proud of this solution. I like that we broke it down. We've got these nice little functions. It even turned into to this thingy. Very cool. Yeah, Russell was mentioning. So I guess the one that we're looking at, they built three sets or three arrays: normal, transposed, and the regions. So this is rows, columns, and then each individual region. Cool. I did technically have one more kata on my list, but I think I'm gonna go to bed. I have work in the morning. It was matrix determinant. Let's save this one for next time. And actually, I think I could use similar code from the Sudoku that we just solved, because when you're determining the matrix determinant, you have to find the determinant of like sub matrices. And so this get region function that we wrote is getting basically like a sub matrix inside of a bigger matrix. But I think I'm going to call it there. Wally's saying, refresh the last kata page before you start and see if it doesn't show 1,000. No, it does. I've unlocked a new privilege! 1,000 plus honor! You are now 2 times kata voting power. What? Cool. Yeah, it's still 1,000. Awesome. This was a good stream. We solved problems. We wrote cool codes. We made it to 1,000 points. I'm satisfied. So yeah, I'm gonna end it there. I'll push up all the code that I wrote today, and then next Wednesday I'll be sure to do matrix determinant. Thanks everyone for tuning in. Thanks for participating and for all your suggestions in the chat. I don't have a stream schedule yet, but soon. That's all I'll say is soon. Awesome. Thanks everyone for tuning in wherever you are in the world. Have a wonderful morning, afternoon, evening, or night. We'll see you next time. Here's this.